evening, grade 9s. Welcome to video 7 of our Year 9 Geology unit. I'll just rearrange that. History of tectonic theory. So we're going to kind of look at how the theory was developed and sort of the main ideas that Alfred Wegener had in order to figure this out. So here's our Walton and Wilfy, and look at how Alfred Wegener developed the basic idea of continental drift. Now note, you might hear me pronouncing it with a V sound. It is because his name is German, so even though it's spelt with a W, it's pronounced with a V sound. And we want to recall the evidence that Wegener had, and we're going to repeat some of these observations. Reason we're doing this is science is not a static body of knowledge, and understanding should change when presented with new evidence, even if the idea seems absurd to you at the time. Just because something seems crazy and outlandish, if the evidence is good and you can repeat the methodology, then you sort of have to go, well, maybe there's something else here that I'm just not getting, and give it a shot. So, I like to do a puzzle exercise with the class. What I'd recommend you do is grab a picture, just cut it up into different shaped pieces. Don't make really tiny pieces, otherwise you'll be there for ages. And try to make them different shape. If you just make them all rectangles, it makes it a bit harder for yourself. So give them some different shapes, mix them up, and then try and put it back together. And if possible, get someone else to do this for you and put together their puzzle. So, I don't know, maybe grab a sibling and make some puzzles for a second. And then ask yourself, what strategies did you use to put the puzzles back together? Now pause the video, stop the video, go and do this. It's really important that you do. Okay, now hopefully you're back from making the puzzles, and if you have had a bit of a think about what strategies to use, you might have gone, well, you were looking for shapes. Okay, so you're looking, well, this shape kind of fits with this shape, so maybe they go together. You might be going, well, I looked for details on the pattern. For example, if I have a bit that's got a green streak running through off to the edge, well, the next piece is probably going to have some green on it as well. If I'm not going to put a piece with blue next to a piece that's green, unless there's 100% fit and it can't go anywhere else. But it likely would say that they're not going to be next to each other. It's very rare for a puzzle to have something just entirely finished right on the edge. Not entirely unheard of, but very rare. And you might go, well, I did the edges first. And that's definitely a very puzzling. That's not going to help us for our understanding of Wegener's. But those two core ideas there, shape and pattern, that's what Vagner did, but his puzzle was a bit bigger. His puzzle was the Earth. So have a look. What can you see kind of looks like it might slot together? So I'm going to go through a couple. One, the Americas. So this part here, South America, could quite snugly fit under there. And if we wrap this around, we could put Africa here, wrap the Northern Americas down a bit, and have it touch onto the side of Africa. So they kind of look quite close to each other. Madagascar, off the coast of Africa. Australia and Papua New Guinea. These kind of look like they would slot together. In fact, there are lots of different places on the Earth where things could slot together. Greenland, North America, Europe and Africa, Saudi Arabia Peninsula and the mainland of Africa there. Okay, a lot of these pieces could connect together. And this is an animation of how we think that the Earth the plates of the Earth, or continents of the Earth, are separated over time. You can see Australia over here, he's going to drift up over this way. The one that I really quite find impressive, you've got Antarctica that goes down, but here's India, and watch India go cahooting up north, smashing into Asia, and hence forming Mount Everest and the Himalayas there. And you can see the North Americas move away from Africa over to the left. So, Wegener, in 1912, he proposed this idea of continental drift. And he put that the continents were moving, which is why they look like a puzzle. he used a few things. He said continental shape, the puzzle pieces, fossil locations, and rock formations suggested this idea, this informed this hypothesis, we say. Geologists and archaeologists and stuff had known about sort of fossil locations and rock formations. The fossils were a little bit hard for them to explain, but they went with the idea that across the Atlantic, because they'd been doing a lot of work in the North Americas and the South Americas compared to Africa and to Europe, and they said, well, no, land bridge. Continents have always been there, but there used to be big bridges through the Atlantic, and they just sank and went away. Okay, but land bridge, the Earth has never changed. Humans didn't really like that idea that the Earth was changing significantly. Now, on eLearn there is a worksheet called like a puzzle activity or fossil puzzle activity. I believe it's called worksheet 7, something like that. Have a go with it, cut it out. Okay, try to line it up. If you don't want to glue it in yet until you see the answer, feel free. But give it a go, because you're doing exactly what Wegener did, and that will help you. Okay, hopefully we've had a go with that now. This is sort of the answer. South America, they're off to the side of Africa, which we saw in a couple of those animations. You've got India, and then Antarctica, and then finally Australia on the end. So this fern, Glossopteris, okay, is found across all those continents. You've got a freshwater mesosaur between South America and Africa. You've got some fossil remains of Sinognathus, something like that. And then there's that land reptile, Lystrosaurus, across Africa, India, and Antarctica. So if we think about, India and Antarctica today, well, they're quite far apart. If you think about Africa and India, well, they're kind of closer-ish, but you wouldn't really expect to find remains of an animal here on Africa, but not up here where, it would at least be closer to the Indian subcontinent with where it is right now. So, one idea is perhaps the animals migrated. One is that perhaps there was a land bridge. Right? The fact that Antarctica used to have plants, that's kind of getting a little bit weirder, because it's the Earth would have to be exceptionally warm for it to be for plant life to be growing down there in the Antarctic. Probably warm enough that the rest of the world would be quite a desert, so that you're not likely to get much growing in Africa or Australia or India. So here's our mesosaurs. So why are they found here and here but not here? Possibly because those areas were once close together. Rock sequencing is also another thing that's found in a lot of places. So if you have similar layers of rocks, two ways could we explain it. One, the areas are once near each other and separated, which is what Vagner went with. Two, they both happen to get pretty similar at pretty similar times, geological activities to cause that layering of rock. The fact that you get some glaciers and some basalt in the same place in two different places at the same time starts getting a little bit, well, I don't want to say impossible, because it can't be impossible, but I do want to say unlikely. So Wegener took these ideas. Oh, here's another good one, fossil. You can see this is a fossil of a fern, and you can see the leaf outlines down there. Where do we normally find ferns? Well, we find them in Queensland, especially up north, going to the rainforests, but this was found in Antarctica. So you don't really get large woody plants with lots of leaves in Antarctica. You get lichen, mosses, but I don't know of any major trees or woody trees. So Vagner took these ideas and proposed something called Pangea or Pangea. You'll hear different pronunciations. And he said that all the continents were once together, and they've moved apart over time. Okay. Separated into two areas, Laurasia and Gondwanaland. They said there was a sea there, the Tethys Sea in between. They gave it a name. And this is what the Earth looked like, according to geologists, about 200 million years ago. You can kind of see, there's Africa, India, Australia over there. So, 270 million years ago, named Pangea. 200 million years ago, Pangea split into Gondwanaland and Laurasia. Gondwanaland was the one that you guys built. Hopefully you built it with that exercise. But here's the thing, this was dismissed. They thought the way Wegener proposed it was that the continent, the bits that we kind of stand on, ploughed through the oceanic crust like, if you've ever seen snowmobiles in movies or in American videos of them just slamming through the snow and pushing it off the side, like big massive boats sailing through rock, which was pretty far-fetched. Okay, the idea that the crust underneath the ocean was still connected to the crust above the ocean, the continental crust, and all that was moving as one big piece didn't quite catch on to the idea. And then didn't know about convection either. So now that we know the convection, the hypothesis is that this causes it. Now this could be dismissed. Okay, we know that the sections of the Earth move. That's definite. Okay, we've got straightforward evidence for that. But now we're trying to propose so tectonic theory is pretty decent, but it's still something we could do more testing on. The problem is, how do we create our own planet? How do we stop the convection current so we can see if it stops the plate movement? That would require some very significant geoengineering, and I don't think we're quite at that point. So Wegener's idea didn't have a how, and that was all the issue. No testable predictions made it very hard for them to test, and so they just kind of got tossed to the side. But as we saw with our earlier videos, Marie Tharp came along, started looking at sonar mapping of the ocean, and she helped prove that, hey, he was actually correct. He just didn't have all the pieces put together there. Okay, so the hypothesis was thrown out, and it took much longer, about 50 years or longer, before his 40 years or longer, before his ideas were vindicated. Sorry, I like to leave it on the black. That brings us to the end of this video. Very short one. Mostly it's just to sort of give you context to the ideas of how these things change over time. Thanks for listening, guys. Have a great evening. Bye.